Howdy, Bryan Vikings. We're going to talk about different types of energy. We're going to look at the different vocabulary terms that set this up. This is mostly just an introduction. We'll revisit energy and really dive into it in the spring, but this is just an introduction. So your Monday, Tuesday attendance is to remember in that lab that we did in the previous week with copper 2 chloride and aluminum. With that reaction shown last week, did it release energy or did it absorb energy? You may have to think back and think about the temperature increase. All right. So what type is this called? Well, if you don't know yet, I'll wait till the end and you'll figure it out. So energy is defined as the capacity to do work or to produce heat. All right, so the word energy is thrown out a lot around in common usage, but this is the official definition. Now, there are three laws that you must know in the world of energy, but the first one is really the only one that's important for this course and for right now at least. So. The first law of thermodynamics says the energy cannot be created or destroyed. It can be converted from one form to another, but it cannot be neither created or destroyed. So the total amount of the energy in the universe is constant and remains the same. Okay? So whatever energy goes in, the same energy has to come back out. So we can convert many different times, and you're probably familiar with the conversion between potential energy and kinetic energy. Potential energy is the energy due to the position or the composition. Very frequently in chemistry, we're talking about the chemical bonds. That's what potential energy is. And then kinetic energy is the energy due to the motion of the object. And so it depends on the mass and the velocity of the object. So now, kinetic energy in chemistry, we're talking about temperature. That's really what we're talking about. So, when you see this, the ball has potential energy, and then as you drop it, right, the potential energy transforms into kinetic energy, right? So there's a conversion of energies that is pulled by the gravitational force and the whole thing. This is not a physics lesson. We're going to move on. This is a lot of physics too, where this is the kinetic energy is 1/2 mass times velocity squared, just to give you a reference point. But the units of that are going to be joules. All right. So the units for energy is joules, in case you see it. J with capital J, which is joules. So back to real chemistry stuff. There are 6 forms of energy we'll kind of need to be familiar with. And now there's actually really only 3 we will look at. We will look at chemical energy, we will look at thermal energy, and we will look at nuclear energy later at the end of the year, which is a lot of fun, my favorite unit to teach. So chemical energy is super cool because it's the chemical bonds. Now the energy stored between the coal right here and its energy density can be released in the form of heat. You can also do a similar thing with gasoline. That's how your engine is able to move. There's chemical energy in the gas. There's also chemical energy in these batteries, and it's converted to electrical energy. We will hopefully get to a chance to talk about that at the end of the year. Now, your food does the same thing as well. It's chemical energy. Now, thermal energy, this is not on the test, but not on the Unit 3 test, but there is convection right here. There are 3 types of thermal energy. There's convection right here, which is the convection between currents. It's like the hotter stuff is on the bottom, and then the colder stuff is on the bottom, hotter stuff is on top. And it's like the rotating current. Conduction is where heat travels through actual matter, and then radiation is when it travels through a gas. Okay, is when heat travels like that. Okay, so Temperature, which is an intensive property, is the measure of the average kinetic energy, usually measured in Celsius or Kelvin. And then there is something called heat. Temperature and heat are different things. All right? So I'm telling you this to tell you this part. Heat is talking about the heat going into a system or out of a system. Okay? Because heat is always like the transfer of something going from a high temperature to a low temperature. That is what heat is. It's heat moving from one thing to another thing. All right. So, and heat is dependent on mass, so it's an extensive property. So it goes in to the system, or it can go out of the system. On the outside, you have the surroundings. So the system is our reaction. Okay, I like to draw a box and think of that as a system. And then the surroundings is everything else. So if heat goes into the system, it is known as exothermic. Now if heat goes out of the system, it is known as endothermic. This is what you need to know for the test. Alright? I told you about temperature and heat, so I could tell you about this. Okay? So exothermic reactions are heat leaving the system, and endothermic reactions are heat entering the system. Okay? Now, a little bit more about those. So exothermic reactions are when heat is being released. Okay? Heat is going out of the system. It feels hot. So if you burn something, let's say octane, something similar to octane in your gasoline, plus oxygen, and it makes carbon dioxide and water, and it also produces heat. This energy is over here on the product side, so it's on the right side of the equation. That means it's an exothermic reaction. So exothermic reactions have their heat term on the right side of the equation. Now, we'll get to endothermic in a second, but I'll give you a couple guesses where that one's going to go. So exothermic reactions also show a profile here. So if you have the reactants, and you start with the reactants, you have energy on the y-axis, and you have the reaction progression or time on the x-axis. As the reaction hasn't happened yet, and then when the reaction starts, there's an increase in energy, but overall there is actually a decrease in energy of the system. That's because the system has lost its heat. Okay? So heat has left the system. Alright? So the energy profile looks like this. It doesn't matter the size of the hump. It doesn't matter really the length of where it is or how big this jump is. You just need to have your reactants higher than the products. Okay? So the reactants are higher than the products. That will make more sense when we see the endothermic ones. So the endothermic is a reaction where it absorbs heat. So the heat goes into the system. Since it goes into the system, it is going in and it is required to do the reaction. So heat goes into the system and it's on the left side of the equation. Okay? And then, it's on the left side. So endothermic has it on the left. Exothermic has it on the right. That's really all you have to know. Now, endothermic reactions, the energy profile is backwards. So we have energy on the y-axis and the reaction progression on the x-axis. So as the reactants are mixed, the reaction starts, it overcomes the activation energy, and then ends up as the products here. Since it gained energy, energy was put into the system, the products now have a higher energy. So heat was put in, or you can see the heat input here. All right. Hopefully that's a very good introduction of endothermic and exothermic. Just to sum it all up, because I know I give you a lot of information, this is what you really need to be familiar with on the test. You need to know types of energy, which is the kinetic, potential, and chemical energy. Just kind of know what they are. Know that chemical energy is the chemical stored in the bonds. Chemical energy is a type of potential energy. And then kinetic energy is your temperature. You can know those things. And then endothermic reaction is where it absorbs heat. Exothermic reactions are when it releases heat. Know which side of the heat shows up on endothermic and exothermic reactions. So endothermic reactions show up on the left side. The heat term shows up on the left side. The kilojoules or the joules shows up on the left side. And then exothermic shows up on the right side. And then you need to know these energy profiles. Okay? You need to know that exothermic, the products are lower than the reactants, and endothermic, the products are higher than the reactants. Hopefully that makes sense. Make sure you study that for your test, because that will be there. So there's a cool YouTube video, I'll post this in Schoology, where a teacher does a very simple demonstration between a reaction with baking soda and vinegar, and the reaction with steel wool, vinegar, and air. So the question I ask you is, what is the vinegar doing in that reaction, as you go and check out this video. So it's a pretty cool demonstration. That's going to be it for you guys. I want y'all to have a great day.